Hello everybody and welcome to this session experience on building database Docker desktop extension. My name is Marcelo Ochoa. I'm the CTO director at Faculty of Exactas Unisen at Tandil. Also I'm an Oracle and DevOps engineer for working for companies on the private side. And in my part-time an open source developer and book author or reviewer. My working on communities are for the OracleXE member since 2006, as Docker mentor from 2016 and traffic ambassador from 2020. Also, I'm one of the founders of the Oracle user group in Argentina since 2012. You can reach me on the media using Twitter at Ochoa _Marcelo, LinkedIn Ochoa, GitHub Marcelo Ochoa, or in my blog post marcelochoa@medium.com. This session is about database Docker desktop extension. Why I made these three extensions? Because I'm working a lot with database in many projects using PostgreSQL and other projects in Oracle at the cloud, Oracle in local mode using XE 21c. And also to connect to Oracle database I'm using a command line tool named SQLcl. So this is why I made this extension. The agenda for this session is answering the two main questions: why and how build the extensions, a little demo time showing all the extension in actions for pgadmin, OracleXE and SQL, and look inside the code to see how to make extension or how I made these extensions. Why? I also need to remark that many developers need a database when working on projects, for example with Java project, PHP project. So why not or is good to have the database tool included on Docker desktop, because Docker desktop now is the core of the development environment on many other many machines. So if we need to connect to the Postgres database to check if some table have the information, now with this extension I can click on the menu and have instant access to the pgadmin utility. Also, if we need an Oracle database, or any developer need an Oracle database, you can get an Oracle 21c running on Docker desktop in only 2 steps. So the idea of building this extension is making time-saving machine. I said time-saving machine because we can switch from these tools only with some click on the Docker desktop functionality. How made this extension? The important remark is I'm a beginner developer of JavaScript or Go programs, so I made this extension only looking for some examples. My first extension that I'm looking for was portainer.io. That's the tool for managing Docker swarm in our cluster. I know this tool, so I go to the GitHub project and download the code of this extension to see how it was made. Also, Docker provide Docker extension samples, so it's another point of a good starting point to see how to make an extension. And the backup extension by Felipe Cruz is the bigger resource to know how to extract all the functionality in terms of example of UI code or Go programs to interact with all the internal functionality of Docker Desktop. So with these three projects, I clone the repo and start replicating the functionality in my extension. If I need more information, I go to Google or Stack Overflow to see more examples. Okay, let's see the extension in action. First, the PCadmin. This extension is for connecting to PostgreSQL database. Let's see on Docker Desktop. First, I need an Postgres demo database that is running on port on this port with this user and on my local host, and the extensions are on the marketplace for the PCadmin functionality or installed manually by me for using the command line. In the case of the PCadmin extension, this is how the extension in action. I don't have any server declared. I can add once using the wizard for connecting to this. This is the host name, host Docker internal, the ports and schema and user by default with the password default. So this is this is how the extension is look like. This is the database. This is the schema example that is in this installation. I can see the tables, query the tables, for example. Look at this. This is the information. This is the execution plan. If I have a complex query, I can evaluate the execution plan to see if this is the correct plan or need to do some rework on the SQL. If I have an store procedure, I can edit the procedure with this functionality. You see the code of the store procedure, execute the store procedure, modify the procedure, so make simple modification, compile again, execute again, and you see the functionality. So this is a fully functional SQL tool, the best tool for using Postgres database is the PCadmin that is provided by the Postgres group and is integrated directly inside the Docker Desktop. This is one of the extensions. The next extension is an embedded version of the Oracle database inside Docker Desktop. How it look like is this. This extension was installed. Once I click on that, I'm looking for the Oracle Enterprise Manager. The Oracle Enterprise Manager is a tool for checking the functionality of the Oracle database. You can see the queries. If I see the queries, I can see the execution plan. Note that this is a complex query and have a complex plan. This is the query. In terms of the developer functionality, if we are develop a project and execute a complex query, sometimes this query have a bad execution plan, so this tool is good to analyze and optimize the query. There are a performance hub to see what happened with the queries in some time, not all the queries, with the time involved on that. Execution statics, query plans, all the useful information for developer or DBA to get a good development. This also check the space usage. Okay, this is the enterprise managed functionality of the Oracle database running inside the Docker desktop and integrated on the UI of the Docker desktop. And finally, to connect to Oracle database locally or in the cloud, there is a tool, a command line tool named SQLcl, that is a free tool provided by Oracle. I integrated this tool as Docker extension to quick access to this functionality. This extension is like this. Note that is like to a Unix terminal include on the Docker desktop functionality. We can connect to my local database. The database started by this extension is connected with this command. Once we are connected, we can execute query. More complex query. Notice that the extension provides a history to quick access to previous command. We can make test. We can describe the table information or the script for creating this table. This all functionality are important for the developer purpose, especially for Oracle developer. If I need to connect to Oracle database in the cloud, this is the help to do that. We need a zip file with the credential, because the database exposed at Oracle Cloud need more security way to connect. I can see how to do that. Now this zip file are the credential for the cloud. Once I set the credential, I can connect to this database and execute similar. See the tables, make a query, describe this table, and any other things. So the tool is a fully functional tool in a command line, but include inside the Docker desktop. We can switch back and forth from the database to the tool directly clicking on the left side of Docker desktop. Note that the Docker desktop is a basement for all our functionality available in a one click. Okay, how to make this extension in the case of me that was a beginner developer of Go and JavaScript. All the extensions are in my Docker Hub GitHub account. You can see the code on GitHub, and this code is mainly divided into functionality. One is the source, including directory VM with Go code, a client directory including JavaScript and React components, a pgadmin directory with a simple patch on pgadmin default image to switch in dark mode by default, and a metadata files including Docker Compose for describing the stack and Dockerfile makefile for building the extension. We can see this on VS Code. This is the project. The project includes the VM directory, the client, and the pgadmin directory. On the VM, the main is the first part, basically a few lines only providing a service for Docker desktop extension named ready, and this service is checking for the pgadmin web server running on this port. Once the pgadmin is up and running, this service return OK, and this service will return true to the client side. Quite simple. Basically, this code was extracted from the samples of the Docker desktop extension. For the UI, which means the rendering of the Docker desktop application, basically is a React component with a linear progress indicator, and once the linear progress indicator finish and the service return OK from ready, the complete pane will be rendered with the information coming back from pgadmin web server. So the first part is showing the linear progress. Once the pgadmin is ready, the pane, the complete pane, is reloaded using this URL. This URL is defined on Docker Compose file. If you see this Docker Compose declare two services, the extension itself and the pgadmin web server, implemented with this container image, and using this variable that define a pgadmin functionality running in local mode. Is different from web server mode. This is the port exported to outside, and declare a persistent volume to store the credential which I need to store, for example, the connection to the Postgres database. Once I define a connection, this connection is stored on this directory and persists the Docker desktop restart functionality. Or if you shut down your machine and start again, all the connection defined will be available for the next time. The Docker file used for building this extension is a multi-stage build divided in two parts. One stage is for building the Node.js functionality. This is the UI functionality for Docker desktop, and the other multi-stage build is for the compiling the Go program, which implement the service for checking the availability of the pgadmin web server. And the other is metadata labels required by the Docker desktop functionality. Basically, this metadata is used on the extension pane when you look for the extension at the marketplace or install it. If you see the extension marketplace, we'll see this information, and this information is defined on metadata of the Docker file. Once the metadata is ready, copy some file to the Docker image and copy the UI from the client builder stage, copy the service from the builder stage. Finally, the cmd command define which program is starting to talk between Docker Desktop and my extension. Quite simple. Finally, there is a metadata file which defines which is the URL of the UI and which will be the socket for connecting between or talking between the VM and the UI. This socket is the same socket as we define in this argument. And that's all. As you can see, the code for building this extension is quite simple, no more than 200 lines, and we have a fully functional extension for using pgadmin 4 inside the Docker Desktop. If we see this on the Docker Compose, Docker Compose, we see an stack that defines two services, the pgadmin extension and the pgadmin web server. If we go to the Docker Desktop, this container are running in this stack, showing two containers. One is the service, the extension itself, and the other is the pgadmin web server, which implement the functionality. And that's all. This is the pgadmin 4 extension under the hood. The other extension is the OracleXE. The OracleXE is an embedded version of the Oracle database running inside Docker Desktop. The extension is using a Docker image made by Gerald Benz from Oracle Corp, and basically is the binary distribution of Oracle database plus the functionality to create a default database when the extension or the database is starting up for the first time. The code also for this extension is at GitHub. You can check out and see in detail all the information. It's divided into main parts: the VM, similar as pgadmin, for checking once the Oracle database is up, and the client directory with the code for rendering the UI on Docker Desktop. The Docker Compose file include the image, and the Docker file and make file are for building this extension. Unlike the previous one extension, this is not a multi-arch extension, so it will run only on Windows or Linux and will not run on Mac using M1 processor, because there are an incompatibility of the Oracle database for running on the QM emulator on Mac M1 processors. We can see the code on VS Code. We have similar directories, the VM and the client. The VM include a simple Go program, very similar to the phadmin, with a service named ready, and this service is looking for this URL. This URL is the URL of the Oracle Enterprise Manager, which is listening on port 5500 on this container. Once the Oracle Enterprise Manager is accepting connection, return true, and this true is received by the client-side code. The React and JavaScript code is similar. We have a linear progress to provide feedback during the startup, and also I added other component to show the starting up process of the Oracle database, because when the Oracle database is running for the first time, it will take a long time, depending on your machine. If your machine have a fast disk or slow disk, will take a few minutes or several minutes. So to provide a detailed feedback, this React component will show on the Docker desktop the process of creating the first time database. Once the database is created, the next startup is quite fast. So this is the rendering, or the initial rendering of the Docker desktop. Once the Oracle Enterprise Manager is accepting connection, the complete Windows is reloaded using this URL. Note that this port differs from the port of the Enterprise Manager. We see the port of the Enterprise Manager was 55, and we are checking now for this port. This is because the Enterprise Manager is talking in HTTPS mode, not in HTTP. There is no problem between Docker Desktop and HTTPS, but the problem is that the Enterprise Manager is using a self-signed certificate, and it is not allowed by the rendering process of the Docker Desktop. So to solve this problem, if we see the stack defined for this extension, the extension includes the one container using the plugin image. The other container is the database itself using Gerald image, with some values to provide the default password. This is the sys password for the Oracle database, and the Scott Tiger user, which is the regular user for testing. No? And the other service is a CADI reverse proxy. This reverse proxy is the trick that I solve the problem of the self-signed certificate. CADI will listen on this port and forward all the requests to the Oracle Enterprise Manager, ignoring the warning about the self-signed certificate. So we exported the CADI port outside the extension, and the Docker Desktop can render the URL in HTTP mode. If we see the stack for the extension, is showing the three containers: the service for the CADI, the Oracle database, and the extension itself. The Oracle database have a lot of log, and the extension have this. So as you can see, this is the only thing that differs from the pgadmin extension, only adding a reverse proxy to solve the problem of the self-signed certificate. The Docker file for this is the same, a multi-stage building functionality for rendering the Node.js JavaScript and compiling the Go code to provide the binary for the service, the metadata, copy all the information to the image, and define which is the service running on the extension. This is the Docker sock used to connect between the Docker desktop and the Docker desktop UI and the extension defined on the metadata. Similar to the pgadmin Docker extension. Finally, the last extension is the SQLcl Docker extension. We receive a lot of feedback and help from Benjamin Granford and Lucas Bernal Perez from Docker.in to implement this functionality, which is more complicated on this side. The VM functionality, which spam a service named TTED, is a service which wrap a command line functionality, which is the SQL service, in a web browser functionality. The client-side rendering is similar, and the metadata file and extra file include a Docker Compose as the other extension, and a login SQL file, which is the welcome information of SQL. This extension is with multi-arch support and include obviously the Docker file and make file for building the extension. The extension is available as GitHub source, and we can see the project here. Look at the directory structure. This client VM, on the VM the main Go, and as I said, this is a little more complicated than the other one because includes two services: a ready service that is similar, and another more complicated service, which is the post service start, responsible for starting the TTID daemon once the extension is started. Also, this functionality include the information to set the TTI in light and dark mode. This is because it's more complicated. Why we need this information or this functionality? Because if we change the setting of the UI from light or the system default to dark, for example, and open the SQL, now the SQL functionality will start on dark mode. Sorry. So this is the functionality that Docker extension require as alignment to the user, no? So to implement this switching between dark and light mode, this Go program start the process, the TTD process, with the correct argument for the temp mode. Temp, this is the temp functionality to check background, foreground, colors from the UI configuration of Docker Desktop. The UI code is like the other, including the part that first call to the service post in post mode, start the start service. Once this service is started or executed, wait for the extension is ready. When the TTID on is accepting connection, ready will return true, and once the extension is ready, we change the iframe information to render the localhost 9890 port. So as you can see, it's a little more complicated, but not a lot to provide this information. So if you see this extension, we can execute Unix shells command. We see the process. The process is the TTID service, which render the SQL command line program. The command line program is a regular program for Unix, for Linux, and the TTID render as a terminal inside the pane of the Docker desktop. If we need some file from the persistent volume, I show this. Look, this extension Docker Compose file is simple because include only one service, the desktop Docker desktop image container with the external port and a persistent directory for storing information between the SQL and Docker desktop or the local machine. If some command of the Docker desktop produce or generate a file, this file will be on the persistent volume. If I need, for example, this file on my local machine, I can simply extract it from the volumes using the volumes functionality of Docker desktop. The volume is this. If we query the information the volume, I see the same files as on the on the extension. If I need some of these files on my local machine, also I can copy using docker cp command. This command will copy from this container. This name is hard-coded or will be the same because the name of this service is generated from the Docker image pulled from Docker Hub. So this name will be the same on all the installations. So we can copy from this container, this directory, this file to my local directory, and we can see the file here. These files are the same as the generated, for example, with the dump command from SQL. This is important to get or put data on the database side. That concludes my session. As you can see, it's not complicated to make an extension if you know which part puts all together in a Docker Compose file, and knowing how the Docker desktop works is quite easy to get all this functionality. Okay, if everybody has or somebody have question, I can answer this question on the chat right now. Thanks to everybody to come to this session. Remember that all the code are at GitHub, and if you have more or you need more information, you can use the GitHub issues to report the answer, the question. Thank you everybody, and have a good time.